Hey folks, Azure Cosmos DB TV. I'm Mark Brown. Welcome. I've got with me a special guest, Justine. How are you?
Hey, good. How's it going, Mark?
I'm doing great. I'm still recovering from build. I don't know about you. That was that was a really hard event. There was a lot going on.
Yeah,
I needed some
we
downtime.
released we released a lot of cool features. It's
We
always great to have see all the improvements come out of build.
we did a lot of cool features, and we're here to talk about one of yours, actually, global secondary indexes. So I guess this would be an evolution of the materialized view feature that we released. Well, it's been some time, I guess, now, but now we're taking this and turning it into kind of the real deal, right? With building global secondary indexes. Is that did I get that right?
Yeah, exactly. We took a lot of learnings from the materialized views feature and we put them into this new feature that has a lot of the same core fundamentals, but we made it a lot more developer friendly, way cheaper to use, and a lot of improvements here. So we're really excited to see how GSIs can help customers really improve their queries and get better cost and performance.
So talk to us, I guess, a little bit about what GSIs are and how they work for users or viewers here that aren't familiar with this feature.
Yeah, I think the main benefit of GSI is improving your query efficiency. So it allows you to store your data with a different partition key so that you can maintain fast lookups for more query patterns. We'll take a look at what this really means with Cosmos DB, a distributed database. So partitioning is really core to query efficiency. If you can include that partition key, you're going to get the best performance because Cosmos DB knows which partition to route your query to. And we've also made it a lot more seamless for actually building these GSIs. So GSI is a pattern that you might already be implementing on Cosmos with a dual write strategy or reading change feed and writing the changes. This is actually how our GSI feature works under the hood. We are using all versions it deletes change feed. But with GSI, we automatically sync the data for you. You don't need to manage that change feed job. You don't need to do error handling and all of the things that come up with actually syncing to sources. It can be really complex. So
So
GSI,
we're handle all the plumbing in there. You don't have to set up
yeah,
your own compute, like a function or whatever, to go and run this thing. We're doing it for you. We cover the
yeah,
cost.
exactly. And one of the improvements that we released at Build is if you had used the materialized view feature, you know there is a materialized view builder, which is essentially compute that hosts the change feed job. This was a provision component that you pay for the compute, you choose how many nodes, what SKU. We got feedback that it's difficult to right size this. So we added auto scale and we took away the management. You no longer have to provision a cluster. You don't even have to worry about the compute at all. It's totally transparent to the user. You just enable materialize or global secondary index and the builder is provisioned and it will automatically start working as soon as you create your first GSI.
Ah, cool. Yeah.
Yeah, this
Making it
really improves
easier.
the developer productivity loop. Yeah.
Yeah, perfect. I mean, that's kind of what we do, right? Just make it easier and better and cheaper.
Yeah, yeah, trying to make things seamless as possible. Cool. So let me show a quick example of how GSI can really help in cross-partition query scenarios and what that means for Cosmos DB. So if we have an application and a database, our app is talking to our database, but Cosmos DB is a distributed database. So it actually has multiple physical partitions under the hood. We can represent this. Let's say there's 3 physical partitions. This means our app is actually talking to each physical partition. In Cosmos DB, if you're using direct mode, I could complicate this much more by adding, 4 replicas for each partition, and it gets really complex, right? And the app needs to know what to go talk to actually get your data back. Now, if you have a container, let's say we're storing user information and we have it partitioned by email. Each physical partition is responsible for a range of values. If I want to find items with the email, justine@email.com, my application knows exactly where to route this. We have very distinct ranges and I can go to the specific physical partition. It's an efficient lookup. But let's say I want to query my users by phone number.
Mhm.
Now my application doesn't know which physical partition to go to. I need to go check all of them, and this can add cost and latency to my app. So with GSI, you can add a copy of this data by a different partition key. And that way your application can target directly to the GSI. Imagine, all the partitions there, and the routing is still efficient because our partition key has changed. So this is really one of the main use cases and value prop for GSI. Let's dig into a demo and we'll see how to create these and how to get the most out of them.
Okay.
So I'm in the Azure portal. I have an account here that is simulating an e-commerce website. So I have a bunch of products and I have a bunch of orders. I've already enabled GSI on this account. I'll just show you, it's in the features blade, so it's still in preview. And if you want to enable this yourself, just go into this blade and you can turn it on right here. I've already turned it on for my account and I've created a couple GSIs. So let's go back to Data Explorer. And if you wanted to create a new GSI, we've added the ability to do this right in the portal. So you no longer need to write a CLI script to create this. You can do it directly from the portal. You can pick your source container here. I've got some GSIs already, so you can't have a GSI from a GSI, but you select your source and you can define the container name, the definition, basically the query that you want to populate data. We'll talk a little bit about that later. The new partition key, we support hierarchical partition keys. We'll also show an example of this. And the throughput. So this is just a container. You can configure its throughput, however much throughput you want for your GSI itself. And you'll notice here, this only gives you the option for auto scale. So because the GSI is automatically populated with the builder, we require auto scale throughput to handle spikes and dips and keep your GSI up to date without ever falling too far behind, getting throttled, so the auto scale helps really smooth out those workloads.
Oh, sorry. Hold on. I screwed up the screen. There we go.
Yeah, so that's a great experience. You can do it right from the portal. There's a bunch of different entry points. You can do it from up here, clicking on your source, and we made it really easy to create these.
If I like doing scripts or CLI, can I create these new ones using Azure CLI?
Yeah, of course. We still have the CLI support and all of those things available. There's actually an example of how to do this using both the portal and scripts in our how-to guide. I think we have an AKA there for the how-to guide. So if you want to take a look either by portal or by scripts, both are totally an option. And you can follow the steps there to use either.
Is there bicep support too, I'm guessing?
Yeah, it's bicep support. There's just the RP name. So, creating your containers throughout all those.
And that's a child within the container resource, I'm guessing then.
It's actually a separate resource. So you'll notice in our little resource hierarchy here, we have our database, and both of these are at the top level. So you have your product container, products by brand. I have a little bit of a spoiler here, products by brand, no composite. We'll talk about some composite indexing strategies. But this is just a container. There are some differences. So you'll notice the icon here is a little bit different. It's an eye. Yep. That's because these are read-only containers. So if I were to go and update something directly here and update it, I'm going to get an error because you can't update items directly in the GSI. They're synced from the source. So this actually improves your write performance, right? You only need to write the document one time, and the GSI builder handles the updates automatically for you. You don't need to actually keep them both in sync yourself.
Okay, very cool.
Yeah. So let's take a look at our products container. We have a pretty simple product, sample product here, and we are partitioning this container on category, which of course works really great for queries that need category. But in my e-commerce website, customers recently have been trying to search only by brand, and they want to search brand across a range of all the categories that we offer. So if I go into our simple console app, we can see how this query by brand is affected by using the GSI or by using the source container itself and executing the same query. So I'll walk you through some of the code here. A GSI is just a container in Cosmos DB. So the code to read from a GSI is the same as the code to read from the source. I've done a couple of things here. First, in my Cosmos client, I'm using my system text JSON serializer. We added this recently. If you're not using system text JSON, it's way easier to configure this. You don't need like a full custom serializer class. Again, none of this is specific to GSI, but just some Cosmos client best practices. And the next thing that I want to highlight I've done here, I'm actually using my create and initialize async function, and I'm passing in all of the containers that I'm going to access because we really want to test performance in this demo. I want to show you the performance differences between the product source and the GSI. With Cosmos DB, as we mentioned, we're opening up connections to all of our partitions, and this can take some time. So if you don't create and initialize, the first request is often slower because it takes time to actually open up all those connections. So what create and initialize does is it just gets all those connections hot and ready to go so that when we run our demo, we get the true request time.
I'm gonna have to update some demos. I haven't used that feature yet. No.
Yeah, it's pretty cool. I want to highlight it. I think it's not super well known. In many scenarios, it probably doesn't matter if one request is slow, but if what you're trying to test is performance, it's always good to start with the
Yeah, I mean, given I write demos and samples for a living, I'm sure I don't know that feature,
right.
or I haven't used it yet. So surprise, folks! New feature. Go check that out. So that'll help.
Yeah, it's actually been around for a long time. I think it's just not very widely used.
Oh
Yeah.
man, unless I'm old, I guess. I don't know what my problem is, but get out there and use that new feature, folks. That'll help with the cold starts.
Yeah. All right. So for this demo, the first time it's really simple. We're just going to run a couple queries to find products by brand. So I'll go ahead and run this, and I've commented out a couple of other things that we'll get back to later. So when I run this, it will start up. Of course, it's going to take a little bit before we see anything flowing through because it is actually warming up all those connections. So it's doing that first before it even prints out, the welcome screen that we have. And now we see it start to query. So let me make this a little bit bigger for you.
Yeah, cool.
And we can see a couple of things. So the first time we ran this query, we're selecting star from C where brand equals Ivana. So this is fictitious brand. And you can see our container actually has 10 physical partitions on our source. So when we run this against the products container, remember products is partitioned by category, we get 10 round trips here. And every round trip has some data return. There's actually a partition that has no products from the Zivana brand, but these all cost RUs. We have to go check every single physical partition. They all take a little bit of time. And we can see the total charge for this is 83 RUs. We found just under 2,000 items, and it took us 5 seconds. So that's a pretty long time. You can see the second time we ran this same query, exact same query, and the exact same data is in both of these. We ran it against our GSI. It still took 2 round trips because with Cosmos DB, you have a maximum amount of data that can be returned in any single request. So we needed 2 trips. But our total request charge was way lower. It only cost us 61 RUs, and it took way less time, about a fifth of the time, 1 second, to get the same amount of data. And that's because instead of checking every single physical partition, we just went to the one we needed. It took us 2 trips, but we only had to check 1.
Yeah, that's great. So you got about 30% improvement in cost, but order magnitude better in speed, and that's latency because it's got to hit all those physical partitions is where you're going to you could pay a significant penalty on these things.
Yeah, exactly. And for a query like this, when you're returning a lot of data, a lot of the work that's happening is actually fetching the data itself, right? You still need to get 2,000 items, no matter where you get them from. So those incremental trips, they do cost a lot. But let's look at our second example, and we'll see a big impact for, especially when you have like a more specific query. So this time we're going to get every property where brand equals Ivana, but this time we want to add a filter. So if you think about a product search website, they're usually filtering on something else. In this case, we're going to look for gloves. And in our source container, we still had to check every single physical partition. We got less than 15 items per physical partition, but we had to check every single one. And our use is about 85. So you can see in this example, 70 items is a lot more reasonable for an e-commerce website. Like a user could actually go through 70 items. They're not going through 2,000 items at one time.
Yeah.
So this is a little bit more realistic. And on our GSI, it only took us 1 trip and it cost 6 RUs. So this is where you see the big difference. Depending on the amount of data that you're getting, like a cross-partition query, if there's data in every single partition, is not always horrible, but it can be optimized a lot, especially for those queries where you're getting a smaller amount of total.
So you got like a 6x performance improvement, and you got like a 12x charge or cost improvement there. It looks like, at least.
Yeah. So this is where you really start to see the big savings. And even the prior one where you're saving 30%, I mean, on an e-commerce platform, that could be running hundreds or thousands of times a second. So even 30% is nothing to scoff at. But if you start to add these more complex queries, it becomes even bigger.
Yeah, and on an e-commerce site, I mean, time's money, right? People don't want to sit around and wait for their search results to come back. They're like, I'm going somewhere else. So.
Yeah, exactly. I just want to show you one more thing before we move on to the other query types. I also have this last argument, which I added. I want to show you like where the time is actually coming from. So if I switch this, before I run this, I'll go down to the code that's actually executing the query. So I'm running the same query code for both my GSI and my source, but I want to look at the metrics. So if you'll see here, we're getting the server-side cumulative metrics, which is actually part of the diagnostics. So if you look on line 121 in our response diagnostics, we're going to get the query metrics for each round trip. And after we get all those metrics, I want to do a couple of things. So we can aggregate the time. This is part of diagnostics. It's a little bit under the hood. You know, I don't expect you to do this for every query, but I just want to show you like where the time is actually being spent. And there's 5 main categories for the query execution. So this doesn't include network time, right? After you look at these 5 things, you still have network time. It's not included here. But the query execution is actually broken down between loading the documents, so loading them from memory on your container, writing time, so writing the new documents that'll be sent over the wire, the index lookup time, query preparation time, and then runtime execution. So within a single query execution, there's actually a lot of things going on. And if you wanted to debug, you know, where is the time being spent, you can look at these things. So I'll run just the exact same query. I've enabled these metrics collection on just the first query that we're going to run. Again, it's going to take some time to warm up those connections.
Yeah.
And then we can
by
look
the way,
at
folks, I'll put a link to her code here. But if you're writing apps and you're optimizing and tuning for performance, you need to do this. So pay attention.
Yeah, this is it. We have a lot of diagnostics that can really help you debug. I think not a lot of people know about them, so I really wanted to highlight. And if I just highlight, you know, this part on the screen here, so we still have all of our trips. We're printing out a lot of the same data, but we also have the query execution time, so we can really break down what is taking the most time. And as we mentioned, you know, we're loading 2,000 items, which takes some time. So you can see these first 2 by far consuming the most amount of time on this query. And even when you're looking at your GSI, it looks a little bit faster in this exact example. If I did an average, you know, across 10 executions, they'd probably be a lot closer. But you can see on both the GSI and the source, the most amount of time for this query is loading the documents because we have 2,000 items coming back. And a lot of the time that's missing here is that network time. Though that's where all these round trips to check every physical partition on the source is really the most expensive, is like that network transit time of physically checking all of those executions. So
yeah, cool.
Yeah. All right. Let's look at one more thing, which is on the second query. I actually did 2 optimizations, and I want to highlight this. So if we have this query, select star from C where brand equals Ivana and name contains gloves. You can think of contains like a range query, meaning we're not doing an equality match for one thing, but we're checking a range of values. And anytime you have a range query with some other filters, you might want to think about a composite index. So I've actually added my GSI, but I also added a composite index. And I will show you just the composite, the same query, only with the composite index. I have a GSI with no composite and a GSI with composite. So you can see.
Is a scan or a seek?
Uh-huh. Oh,
Does
contains
contain, is it doing a
it
sync?
is it's scanning. So it can use the index, but it is like scanning across the items in your
Okay.
container. Yeah. So if we show this query, similar query shape, different values here, but on my first container with no composite index, this actually cost me 54 RUs versus my GSI with the composite index, it only cost 10. So don't forget about composite indexes and all of the query best practices. Just because you're using a GSI, you can still further optimize it
Yep.
and really use the full query surface area to get the most out of it.
Good point. That's right. Don't forget about those.
Yeah.
Also, and computed properties is the other one as well. They can save you some money in there.
Yeah, exactly. So computed properties are a great tool you can use even with the GSI. If you had a computed property on your source, it doesn't automatically transfer over to your GSI, but you can add them again in the GSI container and still take advantage of them, index them. Everything that you would have done in your source, you can also do in the GSI.
Can I apply a full text index to my GSIs?
Yeah, exactly. So you can do full text, vector search.
Okay.
GSIs have the full query
Okay.
capability available
Got
for
it.
them. So that's actually one of our common use cases is if you want to isolate, maybe you've got some really expensive vector search queries, full text queries, and you want to isolate part of your workload in the GSI, maybe have a different partition key for some of those. That is still possible. So that is definitely one of the ways that we see customers using
So
this.
you could build a GSI kind of focused or optimize the text or the properties you're putting in there, put a full text or a vector index on those, and then basically just optimize through that GSI and use those other features like full text and vector query in there. So
Yeah,
yeah.
exactly. So let's talk a little bit about the GSI definition. I'll switch back over to the portal. And the first container that we had, we just did select star. So the data is exactly the same in our products. Like all of these properties are in our products by brand. But, speaking of these use cases where we say like, oh, I want to optimize, what does that mean? I also have an orders container. So this orders container has my order ID, my customer ID, a bunch of products. I have date, payment, shipping address, etc. So let's say I want to query. Most of the time, I'm querying by customer ID. So my orders is partitioned by customer ID here. But let's say maybe for some of my shipping flows, I want to query by address or by zip code. So I have a GSI created here. And notice there's a lot fewer properties. So in my GSI definition, I'm using projection to control the data model of the GSI itself, and I can have a subset. This also makes my writes cheaper. This is about half the amount of data. So my writes are way cheaper than writing a bunch of extra data that I may not use.
That's cool. Could I take and uh, do aggregates on data in here? Like, could I build aggregate like you had the orders within there, and here you're doing it by zip. Um,
Yeah.
but
So
could I project the zip up to the root within that because that's baked? That's basically an object within that JSON.
Yeah, so right now you have to project only the top level properties. So if we look at orders, all of these were top level. So I'll show you the query definition that I used. So if you'll notice, I'm projecting c.payment and c.shipping address. That's the top level property. Now, if I wanted to project a nested property, let's say c.shipping address or shipping address.zip, that is coming soon. So we are constantly expanding the query definition scope that we allow, and nested properties will be coming soon, probably late summer. So definitely look for that. And we'll be expanding the set of capabilities for our query index definition over time.
Okay. Could I do some kind of simple aggregates using GSIs?
Aggregates aren't supported. And so right now we have a one-to-one mapping of items. So while you can reduce the number of properties in each item, there's still one item in the GSI for every item in the source. An aggregate would be like, count again, against
Account,
brand or something like that. Yeah, we don't have that supported.
Okay.
So right now it's, you can think of it as one-to-one item mapping.
People should use Fabric for that stuff anyway, right?
Right. So. Yeah, exactly.
use an analytics platform for
Yeah.
So
one last thing I want to show you before we jump back into the demo code, just to show one query with this orders setup, is my container partition key. I'm actually using hierarchical partition key. So we've recently added support in GSIs. You can have a hierarchical partition key in both the source and the GSI itself. And notice in my partition key, I am using a nested property. So I'm partitioning on shipping address, zip code, and my second level is shipping address, street. Maybe if you wanted a third level with like city or something, depending on your actual query pattern. So that is supported. You can still partition based on any valid property, if it's nested or not, or top level. Whatever is supported as a partition key in Cosmos DB can be a partition key in GSI.
Yeah, that's cool. Yeah, I like that. That's really great. Hierarchical partitioning is great, and people should use that for sure. So that's great that we have support for that here in these GSIs.
Yeah, definitely.
Well, this is very, very cool. Anything else you want to show, or
yeah, let's go back to just one last query. I want to show you a query on this orders container, and we'll see how, talking about like the amount of data really changes the savings that you're getting. So if we run this just one last time for orders, let's take a look at how much more efficient the GSI is for that query by shipping address. And this time we're going to do 2 queries again. So first time, most of our queries are by customer ID. This is against the source container. It only costs 2 RUs. This is pretty efficient, right? But for our second use case, where we want to query by shipping address, zip code, and street, this is where you see some of the big benefits of GSI that we were talking about. So in this case, we're looking for a specific zip code and a specific street. Notice there's only one item that matches, but against the source, we need to check every physical partition. And this time it's even worse than our products example. There is no data returned for any of these physical partitions. So it cost us 2.8 RUs to check every single one, and we got no value out of it. Versus our GSI, which is partitioned by zip code and street, we were able to check one physical partition. We got one item back. It's super fast, less than 3 RUs. And this really shows you, like, again, the benefit of GSI, especially if you have a cross-partition query that is frequently run, you can really get a much more efficient execution.
Yeah, you're running a query, you're looking for data and you can't do a point read. These things are going to save you a ton of time and money.
Yeah.
Yeah, that's really cool.
Yeah. And one last thing before we go, I also want to show a little bit about metrics and how can you monitor your GSI creation. Okay. So if we go back into the portal, let's take a look at the monitoring metrics. We have a metric called Global Secondary Index Catch-up Gap in minutes. And I'm going to apply splitting. I've got a couple different GSIs here, so I want to know which one is lagging behind, if any. And if I zoom in, you could see I did a data load on my orders by zip container, and we had a little bit of lag for a second while I was loading my data. And you'll notice the lag is 1 minute. So this metric is at a minute granularity. And the reason is we're trying to give you an actionable metric. So if you start to see this lag behind by several minutes, you may need to take an action. Maybe you're getting throttled and you need to increase RUs because there's not enough RUs to maintain, the volume of writes. So that's why the granularity is what it is. It's not intended to be, per millisecond view of how up to date your containers are, but it's really intended to nudge you if you need to take some action, increase throughput, and really let you know, like, are my GSIs falling behind or are they up to date and good to use?
So they could set an alert on that threshold when it gets, like, say, over a minute or something, or whatever value they want, and then go and take some action on that, increase throughput until they get that value to where they want it, right? And of course, once it gets back below, I guess you could, I don't know if they could create another alert, I guess, like, okay, that's low, you could probably bring it down, or just say, okay now, and bring it down. I mean, auto scale will bring it down anyway, but at least in terms of tuning this thing, when they're dealing with data loads frequently, they can kind of fine tune their workloads in terms of knowing, like, hey, this is the load you want for your data loads. This is here's how you can do it. So
Yeah, exactly.
yeah, very cool. I like it. Our metrics are just getting better and better and better, aren't they?
Yeah, it's really helpful for debugging things and getting visibility. Like with GSI, they are eventually consistent. So you want to make sure that the consistency level is like satisfactory for your application. And just we're trying to add more visibility to make that easier for the developer to have confidence.
Got it. So they're always going to be eventually consistent. There's no strong consistency with these things because we're dealing with
Right.
a container that's reading off this thing using a query. So yeah, not consistency in terms of georef. If they were using strong consistency, though, this would have no impact on this, basically. So if you're using strong consistency,
Right. This is
you're still going to
outside
get
of the consistency for the account. So your account's consistency is really replication, to the replicas, regions, etc. The consistency of like writing to a container. So that is maintained. But this is the syncing between your source and your GSI. Because we read change feed, it's going to be eventually consistent. We read the item, when it's available in change feed, and then we write it. As opposed to, having a lock on your writes where they need to be both written at the same time, but that really impacts the write availability and performance on your source container. So we wanted to decouple those and make it, as low impact on the source as possible while still providing all the awesome benefits of GSI containers.
Yeah. Okay. This is great. This is great.
Yeah.
Well, let me ask you one more question. So when I use change feed, there's always a little bit of tax on the source container when I'm reading from it. It's the same, I guess, because we're using the same mechanism. So there's always going to be I guess, a point read when it's joined the checkpoint in there to go see if there's new stuff when it goes and pulls it, right? So it touches that source container, but it's minimal, just like change feed would be, right?
Right, exactly. It uses all versions and deletes change feed under the hood. So it is querying for new changes and reading data, but it's really a small amount of RUs compared to the write operations. And that's because change feed is efficient, right? It's even more efficient than a point read. It's not reading every single item individually. It's getting you batches of changes. So the total RU, there is some impact. So definitely, you have to take a look at that and take it into consideration. But it's more efficient than doing point reads on every item or like querying for changes yourself. So
Yep. Awesome. I love it. Hey, and you got to talk about all versus deletes change feed
I know.
as well. We need to do a show on that, don't we?
Yeah, I guess we maybe didn't do a full show on that. I'll come back.
No, we didn't. Did we try? I'm trying to remember. Did we do something back in January?
I did something in Cosmos Conf. So for folks that watch Cosmos Conf, we did talk about it a little bit. Yeah.
That's right. Well, we should do a show anyway. All right. Well, maybe when I get back from vacation, we'll do another show.
Yeah.
So this is cool. I'm going to put up your blog here. So you wrote a blog. This came out, I think, at Ignite, right?
Build.
May, or sorry, Build.
Yeah.
Ever. What month is this? I don't know.
Right.
So people want to read more about GSIs and get links to kind of anything and everything around this feature and try it themselves, aka AMS, GSI Cosmos DB. And then all your samples and everything, people can go here to GitHub and go and check out all the Cosmos GSI demo, including how to do all the query metrics inside there, which they should do. And also they can, add latency in there for network, but that's easy. You just do that yourself in there, right? So so you can capture all that and use that not just for your GSIs to make sure those things are humming along, but also you're doing any tuning and optimization for your queries. That's the best place to start. And then you can go and compare the performance of those source containers to what you're going to get for GSIs when you go. And so you can go and create lots of different ones and then figure out what makes sense for you to go and use. So, well, very cool. I think that's it.
Yeah.
Anything else? Did I miss anything?
No, that's it. Thanks, Mark. And thank you, everyone watching. Please try out this feature. I'm really excited about it. I think it's a really great addition to the data modeling and query performance. So
no, this is great. People that are implementing materialized view pattern or doing things like CQRS or just wanting to be able to have higher performing queries for their data across their containers, this is absolutely a must-have feature for customers.
Yeah.
So go in and check it out, everyone, and tell us what you think. Just let us know on Twitter or Blue Sky or Reddit or wherever, or just let me know. You can come and bother. You can come say hi to me or something like that. So, all right. Thank you, everyone.
Cool.
Thank you, Justine, for joining us. Great feature. I'm super excited. Great getting this out. I think customers are going to love it.
Yeah, thanks.
Okay. Thanks, everyone. We'll see you later. Bye-bye.